Let us start with Dynamic Host Configuration Protocol, that is DHCP. So, in this lecture, we will learn to describe what is DHCP, components of DHCP, why we require DHCP, and advantages of DHCP. So, what is DHCP? As the name suggests, it is a protocol used for dynamically configuring the hosts on the network, such as workstations, personal computers, and printers. DHCP can help in assigning various types of information such as routing information, directory services information, and default web server and mail servers. However, the most important and commonly used information for which DHCP is used is the IP address and subnet mask information. In addition, DHCP can coexist with statically configured hosts with fixed IP addresses. DHCP can also carry out the allocation of certain configuration information to a host on a permanent basis. To accommodate both types of computers, DHCP makes use of a client-server approach. So make sure that if anyone asks you which approach is used by DHCP, it is client-server architecture. Thus, DHCP allows the use of computers that run several softwares as well as computers that run client software. Moving on to the components of DHCP. The use of DHCP on the network requires the following three components. As you can see on the screen, DHCP server, DHCP client, and DHCP relay agent. So what is a server? It assigns the IP address and other information to the clients when they request for information. DHCP client. It communicates with the DHCP server to get the desired information regarding its configuration. This communication can take place when the computer starts. The user of the DHCP client can also initiate a DHCP client request to the DHCP server to renew its information. And the final is DHCP relay agent. It is used to relay client requests to the DHCP server. When is client required or relay agent required? This is required when the DHCP server is yet to assign the client an IP address. Without an IP address, a client cannot use IP routing on its own. A DHCP relay agent helps the client to communicate with the DHCP server when the client does not have an IP address. Let us understand the DHCP process. First, I will tell you the explanation of the picture that you can see on the screen. The client sends a DHCP discover request to the server. Server replies back with DHCP offer. Then client sends DHCP request, and finally server replies back with DHCP acknowledgement. This is how it works, but I am sure that you won't be able to get the clear idea of DHCP process. So here's an example. Imagine a room full of footballers who came there to get their jersey numbers. Let us say there are 6 people in the room, 5 out of which are normal team players and one is the captain of the team who gives each player his number. When a new player comes in the room, he wants his jersey number because he is going to play football but doesn't know who the captain is. The new player will get his jersey number in the following 4 steps. Since the new player doesn't know who he should ask, he simply shouts at everyone, "Is there anyone who can give me a jersey number? Please reply." Everyone present there will listen to him, but only the captain will respond. The captain will shout back at him, "Are you okay with the number 10 for one match?" Since the captain shouted, everyone including the new player will listen to this. The new players will then confirm by shouting, "Yes, I am okay and ready to use 10 number for one match." The captain will then shout back for everyone to hear, "Alright, start using your jersey number 10. Thus, the new player got his jersey number in these 4 easy steps. In networking analogy, the team of 6 players in a room is a network and each player is a node, say a personal computer. The captain is a DHCP server and the jersey number is the IP address. When a new PC joins, it is in need of an IP address to be able to use the network. But it doesn't know which node is the DHCP server, and therefore it relays a DHCP discover message asking, Can someone here give me an IP address? The message is sent to 255.255.255.255, which is the networking jargon for everyone. So everyone receives the message, but only the captain, that is the DHCP server, replies. Since the new node doesn't have an IP yet, the DHCP server has no choice but to reply to all with a DHCP offer message. So are you okay with using IP 192.168.1.10 for 4 hours? The message is received by all the personal computers, including the new PC that requested the IP. Now the node has to reply if it is okay with using the IP given by the server. Therefore, it shouts back at everyone with a DHCP request message saying, okay, cool, I am okay with using the IP for 4 hours. Note that the node has only replied back, that is, it is okay with using this IP, but it hasn't yet started using it. The server now shouts back a DHCP acknowledgement message saying, alright, start using your IP. Since the new node doesn't have an IP yet, the DHCP server again replies to all. And finally, the new node starts using IP. The DHCP server allocates IP for a fixed duration of time, which IP renewable or reallocation will take place. So in this way, this is the DHCP process that carries out in real life. What are the advantages of using DHCP? It sets free the network administrator from the duties of setting up the configuration information. Then it avoids this, and sometimes the same IP address is assigned to 2 different hosts. DHCP makes sure that no 2 hosts are assigned with the same IP address. DHCP is compatible with other devices such as mobile, iPad, laptop, computers, etc. And most importantly, DHCP allows IP addresses from a pool of IP addresses. So, the quick recap of this lecture would be the real-life example that I demonstrated a few minutes ago. Make sure you understand the DHCP process and the operation and the technical knowledge of DHCP. In the next lecture, we will see Internet Control Message Protocol, also known as the complaint box of networking.